I filmed most of this video a couple of years ago when I had these boards made, and then lost enthusiasm with creating the YouTube video. It just doesn't really seem to be the interest in the automatic shifting bicycle projects. But anyway, I found these files on my computer and thought maybe I should try and make them into a video, so here it is.
So it's finally time to replace this prototype board with a custom made one. As you can see, this arrangement here has developed over the last 2,000 miles of riding with quite a few extra additions. There's the EEPROM external one. We've got a power latch circuit for the front dynamo hub. We've got regulator there for 3.3 for the front light and rear light. We've got the power latch circuit tacked on there. We've got MOSFET on the back there for the front light. We've got wires here coming from the wrong end of the circuit board. So let's see if we can tidy all this up and make it all look nice.
I had the boards manufactured in China, and most of the small surface mount components were soldered on for me. They were almost all good, except for a few that were slightly tombstoned, easy enough fixed, and then I soldered on all the larger components and the headers.
So that's all of the wires soldered now. Looks quite neat from this side, reasonably. A little bit more of a mess on the underside, but it works quite well. I'm quite pleased with that. There was these two grounds here for the servo. I've just soldered them together. I was running out of strain relief holes, so that works fine. Next thing to do is to solder on the rest of the circuit board, which is here. Now I'll put the wireless modules on it. And I was going to use this female socket here so that this would be removable and it would just be bolted together, but there actually isn't enough space. It moves this out by 11 millimeters and it would get in the way of the servo pulley here. So I'm just going to solder the two circuit boards together with the header pins, and then there'll be just a little gap, and that should work fine. It's quite a tight fit, but it is actually all fitting. I had to take the pulley off to get it in behind there. And I'm really liking the look of that. It looks really good. I have actually tested this as I'm going along, so it should work. All I need to do next is put the Arduino in, which has to go in the other way up. That's this design slightly different. I've marked the USB there and the grounds, so hopefully I will get it right. So what's left is to power it on. And there we go. And we should get the little LEDs light up. That's when I'm pressing the buttons. And same thing will happen when the wheel and the cranks are turning. So that looks pretty impressive, I think. Really happy with that. Now it's time to put the cover over that and go for a test ride. So that was version 2, and as I'd had more than one circuit board made, I've created this, which is the third version of the electronics for version 1. I still keep it in the saddlebag, which provides good weatherproofing and also dampens some of the vibration off the bike frame. Obviously it has a disadvantage of not being able to use the saddlebag for anything else, but this is designed so that it goes in the saddlebag, so these ends protect the circuit boards. As you can see, it's still very much a prototype. I've got a few loose wires still that isn't ideal, but this Bluetooth module had to be moved in, so I had to put these wires around to extend that. And I've also got a data logger here, which is actually a separate Arduino, which just logs the data of the serial port, and that's on all the time, so it acts a little bit like a black box recorder. It just records everything. That's for monitoring the current Enviolo Extreme hub that I'm testing out. On the back here we have the power side of the circuit board, which is wrapped around to save space. That works quite nicely. And we've got the connector here for the AC from the front dynamo hub, and also I kept the same old 9-pin connector for the rest of the connections. That's the step down converter circuit for the servo. One day I might upgrade to a high voltage servo, so that'll be fed directly from the two 18650s here. But for the moment the servo is still going strong after 19,000 miles, so I'm going to keep it for the moment. And if you're interested in the brand of servo, here it is. This one I keep as a spare, although I've never actually needed it, fortunately. And here's the specifications if you're interested. It's not a particularly powerful servo, around 17 to 20 kilogram centimeters. Not particularly fast either, and as you can see, standard voltage, 5 to 6 volts. And yeah, this should hopefully maintain the reliability of the electronics going forwards on beyond 20,000 miles. And yeah, that's about it to say about what I did with these circuit boards. And thank you for watching.